Hello everyone, this is Dr. Jiten Kumar, Assistant Professor, MLK PG College, Balrampur. Today I am going to talk about a very important rule that was given by Donald J. Cram, that is known as Cram's model, to predict the stereochemical outcome of a nucleophilic addition reaction on carbonyl compound when there is certain features in the starting material. Okay, so now consider this example where there is a carbonyl group in between and two sides are having same groups, and if this compound undergoes nucleophilic addition reaction, you will get either front side attack of the nucleophile to the carbonyl carbon, then you'll get this product, or rear side attack, then you'll get this product. If you see these two products, they are the same. If you put an axis here and rotate it by 180 degree, you will get this compound. That means these two compounds are same, so you'll get same molecule. You can see here there is another perspective of the same molecule. Here you can see that this molecule being sp2 is planar and is having two sides. Now what will happen if we have two different substituents on the carbonyl group, like this one side is having hydrogen and other side is having benzyl group. Now, if nucleophilic addition takes place, if the nucleophile attacks from the front face, top face, you'll get this product, and if the nucleophile attacks from the rear face or below face, you'll get this product. Now, interestingly, there is a formation of a chiral center. Now, there is no other factor influencing the ratio of these two compounds. The bottom attack or and the top attack will be of equal probability, and you will get a racemic mixture where the pair of enantiomer will be formed in equimolar amounts. Now consider this example where the alpha carbon is already asymmetric. Now it will also give you two products depending on whether the nucleophile attacks from the top face or the bottom face. But the question is, will that products will be formed in the same amount, or will there be any difference? So here alpha carbon is asymmetric. You are doing the same reaction. When the nucleophile attacks from the top face, you will get this compound. If the nucleophile attacks from the below face, you will get this compound. Now, the stereochemistry of this carbon, newly generated carbon, is changing, but the stereochemistry of the already existing asymmetric center is retained. That means these two molecules are distereomers. And since the nucleophile, if it attacks from the top face or the bottom face, will face different kind of sterics. That means these two products will be formed in unequal amount. Now this is also called asymmetric induction because of the asymmetry of in the starting material. There is a formation of unequal amounts of the product. Now the question is, this product will be formed in the major amount or this product will be formed in the major amount. Here comes Donald J. Cram. He also received the 1987 Nobel Prize by doing the work in the asymmetric induction and these areas. So in 1952, by studying various examples of similar kind, Cram made an attempt to predict the formation of major stereoisomer based on steric hindrance. And this is his paper, which was published in JACS in 1952. Here the title is Steric Control of Asymmetric Induction in the Synthesis of Acyclic Systems. So here he writes that a non-catalytic reaction of the type shown that diastereomer will predominate, which would be formed by the approach of the entering group from the least hindered side of the double bond. But how to decide this least hindered side? That carbonyl double bond is flanked by two least bulky groups. So I have written the same thing here. There are three things are very important: approach of the entering nucleophile from the least inner side of the double bond, and where the position of that double bond will be of that rotational conformation where the double bond is flanked by two least bulky groups. Now If I have this example, which I have already taken, excuse me. So this molecule along this carbon-carbon single bond, it can rotate and gives you infinite number of rotamers or conformers. Here, if you see all these three examples on the top, the carbonyl double bond is eclipsed with this group. In this, there is a pH. In this, Me. Then in this, there is hydrogen. But what Cram told, that this carbonyl double bond has to be in between the two groups, and that those two groups has to be of the least size. So if we see the here, the carbonyl is eclipsed with one of the alpha substituent, and if you see the bottom three rotamers, the carbonyl is flanked between two groups of the alpha substituent. Here the carbonyl is flanked between pH and H. Here it is flanked between Me and pH, and here it is flanked between H and Me. So if you see this particular conformation, here the carbonyl is flanked between two least hindered group, because if you consider the steric bulk of pH, Me and H, you will find that the steric bulk of pH is more than Me, and Me is having more steric bulk than hydrogen. So he said that this particular conformation will be the reactive conformer, and this will decide the outcome of product ratio of those diastereomers. In another perspective, if we look from this side, we can form the one projection. Here, this carbonyl hydrogen is because of this sp2 carbon, it is represented in plane, and these two groups are here. So what you have to see, that on the basis of the steric bulk, which is already pH is having higher steric bulk than Me and so on, you define these three groups as large, medium and small. Now the nucleophile will attack this carbonyl carbon from either this side or that side, and it is obvious that from the nucleophilic attack will be favored from the side of a smaller group, and that's what Cram said in his paper. So that means if we consider this hydrogen and Me, here the hydrogen is having a smaller bulk. That means nucleophile will come favorably from the top phase. That means OH will go down. That means this product will be major product. Now I am retaining this part as same as was in the question, but to make this particular stereo center, I am considering this rotational conformer which was following the Cram's rule. That means this product will be major product and this product will be minor product. Thank you all.